and I wanted to do some questions from our quantum physics packet. First up is number 6. An X-ray photon scatters from a free electron at rest, scattering an angle of 75 degrees. If the scattered photon has a wavelength of 0.32 nanometers, what is the wavelength of the incident photon? So the equation I'm doing is the Compton shift, y minus y naught equals our constant of h over me times c times 1 minus cosine theta. So plugging in our numbers here, it would be 0.32 times 10 to the minus 9 meters minus the original wavelength equals 2.43 times 10 to the minus 12. That's all of these constants combined together. 1 minus cosine 75 degrees. Do make sure you are in degree mode. And so I get the original wavelength to equal 3.18 times 10 to the minus 10 meters. Over there. There we go. Then for part B, to determine the energy of the incident and the scattered photons, for the incident, I can do E equals hc over lambda. So 6.626 times 10 to the minus 34 times 3 times 10 to the 8th divided by 3.18 times 10 to the minus 10 meters. So that would give me 6.25 times 10 to the minus 16 joules. And for the scattered energy, same thing, E equals hc over lambda, h 6.626 times 10 to the minus 34, 3 times 10 to the 8th, divided by 0.32 times 10 to the minus 9th meters. So we do 6.21 times 10 to the minus 16 joules. To find then the kinetic energy of the recoiled electron, we use conservation of energy, where energy of the incident photon has to equal the energy of the scattered photon plus the kinetic energy of the electron. So my kinetic energy of the electron would be 4 times 10 to the minus 18 joules. What is the speed of the recoiled electron? Ke equals 1/2 mv squared. So if we plug in the kinetic energy as 4 times 10 to the minus 8 joules, that equal 1/2 the mass times velocity squared. So velocity is 2.96 times 10 to the 6th meters per second. Then I'd also like to do number 7. A certain metal has a threshold frequency of 1.5 times 10 to the 14 hertz. What's the work function? So I can do the Ke max equals hf minus phi, where this would be 0 when we're considering the threshold frequency. So h, the cutoff frequency or threshold frequency, would equal phi. So 6.626 times 10 to the minus 34 joule seconds times 1.5 times 10 to the 14 hertz would give me 9.939 times 10 to the minus 20 joules. And to convert from joules to electron volts, I use the fact that 1 electron volt equals 1.6 times 10 to the minus 19 joules. And so this would equal 0.62 electron volts. if the metal is then irradiated by light of wavelength 3 times 10 to the minus 7, what's the maximum Ke? So Ke max would equal HF or I'll have to do HC divided by lambda because it was given as the wavelength minus the phi of 9.939 times 10 to the minus 20 joules. I use the one in joules because my H value was joules per second and all the rest of these things cancel out so that we would get joules for this part, so my energy would be in joules. So my maximum kinetic energy in joules is 5.63 times 10 to the minus 19 joules. If I convert that then to electron volts, it's 3.52 electron volts. Again, Ms. Glover warns that you want to make sure you always work in joules and then just convert if you need electron volts. Just because AP Board can take a photoelectric problem and then change it into like a mechanical energy problem. And the next one I wanted to do was number 15. And to get the de Broglie wavelength of an electron starting from rest and going against 20 kilovolts, I first did the electric potential energy equals kinetic energy. So QV equals 1/2 mv squared. It's 1.6 times 10 to the minus 19 coulombs times 20 times 10 to the third, because it was kilovolts, equals 1/2 times 911 times 10 to the minus 31 kilograms times v squared. From that I'm able to solve for the velocity to be 8.38 times 10 to the 7th meters per second. And de Broglie wavelength is lambda equals h divided by mv. So take your 6.626 times 10 to the minus 34 divided by the mass of an electron, 9.11 times 10 to the minus 31 kilograms, times v, which is 8.38 times 10 to the 7th meters per second. And that we get a wavelength of 8.6 times 10 to the minus 12 meters for the de Broglie wavelength. And lastly, I wanted to just look at 18 very briefly, where 18 is a graph problem, photoelectric effect, pretty common of what you might see. For the first part, this shows max Ke versus frequency. Find the slope of the line. Remember, when you're trying to find the slope of the line, choose 2 points on that line. I like to choose 2 easy ones to kind of find my slope. And then you can do rise over run. And all in all, I found that the slope is 7.11 times 10 to the minus 34 joule seconds. What should the slope equal? This is approximately an H value. Remember from the equation, Ke max equals HF minus phi, or this is like Y equals mx plus b, so the m part is H. What's the cutoff frequency? You'd read that as the x-intercept. So that would be 4.4 times 10 to the 14th hertz. And how would we find the work function? We'd have to extrapolate, kind of add on to our graph, and continue this all the way back and find the y-intercept. Or you could also use phi equals h times the frequency cutoff. Those are 2 ways you could use kind of your graph to find the work function. Thank you so much.